This is R.D. Sharma Solution Class 12, Chapter 9, Continuity MCQ Multiple Choice Question. The function fx is equal to this one. So there are four options and we have to tell it is discontinuous at 1 point, 2 point, 3 point. For that you just have to check what is the denominator in this case. For example, if fx is given like this, 4 minus x squared divided by 4x minus x cube. So any function, when it is valid, when it is not giving you the form of this 0 by infinity, 0 by 0, infinite by infinite, or infinite by 0, these are certain examples that we don't want this kind of thing because it is not describable. For that we have to see the denominator and we have to see what value does this gives so that it becomes valid. So I am taking x common from the denominator. So 4 minus x square, 4 minus x square. So you will be tempted to cancel these two. So only 1 by x will remain. So the answer will be only x should not be equal to 0. This is one point. So you will be tempted to answer the first one. But it is not like that. What we have to do is x is not equal to 0 is one case, but 4 minus x square can also be 0. 4 minus x square cannot be 0, otherwise 0 will be there in the denominator. So 4 minus x square equals 0 has to be taken care. So when is 4 minus x square equals 0? When x is equal to plus minus 2. So there are 3 points, 0, plus 2 and minus 2. How many points are these? Count these. These are 3. So fx is defined and continuous for all real number except these 3 points, 0, plus 2, minus 2. So this fx is discontinuous exactly at 3 points which I showed you. Now this question, we have fx is equal to mod x minus a phi x. Now phi x is already given in the question that it is continuous function. So which one of these is okay or perfect? Because a plus in any number line, if you are talking about a plus, we are just adding a very small number, very infinitesimal small number, a plus h. H is that tends to 0. A minus h on the left hand side. Since we have this as f dash, so what we'll do here, we will try to find out the differentiation or f dash using the first principle. So f dash a plus, let us see what we get. So wherever a is there, x is there, just put it as or replace it with a plus h. So limit h tends to 0. So the first principle, it will be fa plus h minus fa divided by h. So wherever x is there, just replace it by a plus h. So here we have a plus h minus a, this is phi x. So just write a plus h in place of x minus, now in place of x just replace it by a, so mod a minus a and phi x, and divided by h. I am not dividing it, we'll just solve the numerator and then we'll see. A minus a is 0, so this whole goes 0, this term you can eliminate. Here you get mod h, and then we have phi a plus h, right? Now mod h, so h, because h is a positive value, we are talking about a positive value, so mod of positive value will be positive only, so phi a plus h it will be. Now we have the h in the denominator and let us apply the limit now, but h gets cancelled, so phi a plus h 0 in this, so phi a will come, and phi a is continuous already given in the question. So the first thing is this one is the correct. We have to check others also. For example, the f dash a minus we are going to find out. A minus is wherever x is there, just put a minus h. So limit h tends to 0, fa minus h minus fa and divided by h. So a minus is simply a minus h. H is a very small positive value which is subtracted from a. And divided by h, this is the first principle. Replace x by a minus h. So a minus h minus a, phi, in place of x replace it by a minus h, and then we have minus mod a, just replace it by a minus a, mod a minus a, and phi a. Now I am not writing the denominator, first you see here a minus a is 0, so just cancel it out. So what do you get? Mod minus h and phi a minus h. Now you see very carefully, denominator you have h. Now this is mod minus h, but h is a positive value. As I said, h is a positive value. So what do you get? It has to be x is mod x. When x is greater than 0, it is mod x is x. When x is less than 0, it is negative x. So when we are talking about the modulus of minus h, it will give you a negative value, right? You can always think like that, minus 1 into mod h, it is positive. So in this case, when we are dealing with h and the variables, not the values, when we are dealing with the variables, you have to see if x is greater than 0, it is x. If x is less than 0, it is negative x. So here it will come as negative. So minus phi a minus h will be a minus h. Okay, let us apply the limit now. Limit h tends to 0. So this is going to be 0 minus phi a. So what is this? This is your second thing which is true in this case. There are two things which are correct here. Now fx is equal to modulus of log base 10x. Then at x equals 1. So we'll check this at x equals 1. So we'll try to resolve it first, because you need to know about logs. How do they behave? And then only you will be able to solve this type of question. So we'll resolve it. This fx is given as log base 10 is an x. So you can write it like this. Take the base as e. So it will be log base ex divided by log base e 10. This is how you can write. Okay. Now this is a constant, and when you take it in the numerator, log x will remain like that, and then this 10 and e will replace their places. So log 10 e it will be, and this is a constant, so you don't have to deal with this. It will be a positive value. 10 to the power something is e. 10 to the power something is e. So assume it that this is a constant. I will take it outside and try to find out what we get. Okay. But log ex, here we are going to apply the f dash x. So f dash 1 plus, because the question is asking about that. So when you are talking about 1 plus, you have to replace it by 1 plus h. X by 1 plus h. And for the other side, it will be 1 minus h. So f dash 1 plus means 1 plus h you are applying here. So f 1 plus h minus f1 by h, limit h tends to 0. So we'll talk about limit h tends to 0 and denominator h later. First let us solve this. So 1 plus h, in place of x just replace it by 1 plus h. This constant I am not dealing, because it is a constant, it will come outside. So we don't have to write it again and again. Just assume that this constant is there and we can take it outside. Let us talk with log base e 1 plus h. And this is in the modulus, minus log base e, and then we have 1 here. 1. And log 1 for any base is going to be 0. Please remember, it is basically e to the power something which is equal to 1. So e to the power something, anything to the power is 1 when the anything is, the power is going to be 0. So this is 0. Log base e 1 or log 1 is simply 0. Just replace it or eliminate it. So we have log base e 1 plus h, and in the denominator we already have a h, and limit h tends to 0, and we know that log 1 plus h divided by h, limit h tends to 0, is going to be 1. So this whole, if you apply the limit, this is going to be 1. Now I told you already that log e to base 10 was a constant, so it was outside. So finally the value will be, because only 1 has come and constant was already there, log base 10e. So log base 10e is the final answer, right? This is a final answer. Okay. First one you are getting, but we have to check for log 1 minus also. So I am just clearing it, and we are coming on this second part, which is f dash 1 minus. So you have to replace this x by 1 minus h. So just replace wherever, basically it is f1 minus h minus f1 by h. Replace x with 1 minus h. So remember, when we resolve it, or you can say that log 10x, we wrote it as log e log x. Log e base was 10, log x base was e. But log e base 10 is a constant. So you can just forget it for now. Just assume that it will be outside. We are dealing only with log x. So log x means, and base is already e. So log 1 minus h, x is replaced by 1 minus h, minus f1. So replace x by 1. So log base e 1, and take the modulus here. Okay. Log 1, as we just talked about, log 1 is 0. So replace it by 0 or remove it. Now log base e 1 minus h. Now as we know, log 1 plus h by h is equal to 1 when we apply the limit h tends to 0. But since we have log 1 minus h by h, so what do? We can assume this 1 minus h, or we can write this 1 minus h by 1 plus minus h, and the denominator is h, so you need a negative h. So multiply numerator denominator by minus 1. I hope you got the idea. We need to get log 1 plus h divided by h, and limit h tends to 0 is going to be 1. But since we don't have 1 plus h in the numerator, so we just need to use some trick. The trick of solving this is simply, you can write the numerator as log base e 1 plus minus h, and the denominator as minus h. And since you have introduced a minus, there will be a negative in the numerator also. So let me write it as 1 plus minus h. Okay, and denominator also you have minus h. 1 plus minus h, and denominator also negative h. Okay. So minus h it is there, and minus a negative will be always there because you have introduced negative by yourself. Okay, let me tell you again. Log 1 plus h by h is 1. We are not getting log 1 plus h here. So log base e 1 plus minus h we have done, and since the denominator only has h, we need a negative h. So you need to multiply numerator denominator by negative 1. Okay, now limit h tends to 0. This is the whole form which we wanted, and just assume it to be 1 plus say k or x, because 1 plus k by k, limit k tends to 0 is also 1. Only negative has come, and as I told you, the constant is already there, log base 10e. So minus log base 10e. So what is the answer here? This one, the last one. So what is the answer here? This one is correct, and this one is also correct. There are two things which are correct here. Okay, this will take some time, so we'll deal with it in the next discussion. Thank you so much.